see so many folks here, and I'm glad to walk through this introduction to the DesignPH tool. The DesignPH tool is obviously a really important piece of our Psi-Values toolkit, and unfortunately, it's not one that's commonly used by many practitioners. So I am happy to get started here, get everybody started on using this DesignPH tool, because I do think it's a really critical piece of our Psi-Values toolkit. So as I said, this is a getting started webinar. This is going to assume that you don't have any prior knowledge about DesignPH whatsoever. Again, just a super quick introduction to myself. So as I said, I'm primarily a Psi-Values consultant, trained as an architect. I'm licensed architect, but don't really practice as a traditional architect any longer. Nowadays, we work entirely as outside specialist consultants, helping other teams get their projects to the Psi-Values level of performance or achieve the Psi-Values certification standard. We work both PHI and PHI US, and both in the US and Canada. And as I said, I'm really lucky to, back when we could leave the house, be able to train lots of really amazing practitioners around both the US and Canada in the Psi-Values standards, and have taught a lot in past years at Stevens Institute of Technology, just over in Hoboken, and Parsons, the New School here in Manhattan. So again, great to meet you all. We'll look forward to hearing your thoughts as we get into this session. So what are we going to cover in this session? We'll keep it to about an hour. Well, really, I'll try and keep it to about 45 minutes. We'll make sure that we have some room for questions at the end, and do a little bit of live demo to make sure everybody's sort of following along. But I want to cover some of the most basic issues around DesignPH. So if you've never used DesignPH before, if you're confused about what it even is, how you even install it, that kind of stuff, I want to answer a couple of those questions and just lay the groundwork for DesignPH moving forward. We'll talk about the basic workflow for DesignPH. So how does one employ it within Psi-Values projects? What are the basic steps that we would move through? And then we'll look at some of those steps in quite a bit more detail. In particular, we'll take a look at some of the basic modeling procedures, rules of the road, best practices that we would employ when modeling for DesignPH. We'll talk about tagging and associating geometry with parametric information. We'll talk about windows in particular, because they're kind of unique in the DesignPH ecosystem. They're a little bit weird. And then lastly, we'll touch on how we export data from DesignPH out into our PHPP energy model. So that's our agenda here for today. Again, we're going to start from the very beginning with the assumption that we don't have any prior knowledge or experience with DesignPH. So if that's you, that's great. But even if you have messed around with DesignPH, hopefully this will be a good introduction to the series here. And I guess I should just flag, as Andreas was sort of alluding to, what we're going to try and do over the next few months is roll out a whole series of these DesignPH webinars. So this is really the beginning, and hopefully we'll do maybe 8, 9, 10 of them, focusing on different aspects of the DesignPH workflow in quite a bit more depth. So this is going to serve as an overview and introduction. We're not going to go into a huge amount of depth on these various topics. We will have plenty of time to do that in future webinars, future sessions. So stay tuned for those. Oops, sorry. All right, so let's talk about the most basic issues around DesignPH. What the heck is it? How do I make it work? What do I need to actually make it work? So you're going to need a couple things in order to make DesignPH work for you, for your own system, for your own workflow. First of all, obviously, you're going to need a copy of DesignPH. DesignPH needs to be purchased. It's a separate piece of software. You need to get it somehow, and you can get it from a couple of different places. Probably the easiest place, if you're in North America, is the 475 online shop. So that's where we get ours from. It's an easy place to download it. You can also get it internationally from the PHI web store. I think there's a couple different places that you can buy DesignPH from. In addition to DesignPH, you're going to need a copy of the Sketchup 3D modeling software. So DesignPH is not a standalone program. It's an expansion or an extension. It's an add-on to the Sketchup 3D modeling software. So you're going to need both of those things in order for it to work. You're also going to need a copy of PHPP. So in addition to your 3D model and this plugin, you're going to need a copy of PHPP. So in the end, all of our information and data from our DesignPH model is going to flow into our PHPP. So you're going to need all of those elements. As I said, the easiest place to get DesignPH if you're in North America is going to be through the 475 web store. You can just download it right from there. You can choose if you're upgrading from an earlier version or you need to download a whole new version, you can get that there. So that's probably the easiest place. But again, there are other places to get that. So that's our expansion tool. That's going to be core to the workflow that we're going to demonstrate here today. But as I said, the DesignPH is not a standalone program. It's an expansion for the popular 3D modeling program SketchUp. SketchUp, if you're not familiar, is a simplified surface modeling program. It's one of many 3D modeling programs that are available in the world, and for all sorts of reasons, the team at PHI have decided to build DesignPH as an expansion for SketchUp. Relatively low cost, relatively easy to use. In fact, there is even a free version of SketchUp, although it's not nearly as robust as the paid version, as you could imagine. But in any event, you're going to need a version of SketchUp for the DesignPH to run on. This is going to be the tool that we're going to use to actually model our building in. So we're going to need to become familiar with SketchUp and its workflows as well. One of the unique things about SketchUp is that it has a really robust ecosystem of add-ons and extensions and tools and widgets that can be built into or added to your version of SketchUp after you install it. The way that that's done is typically through something called the extensions marketplace or the extensions warehouse. And there are, hundreds or thousands of little extensions that people have built over the years that you can add to your SketchUp program. And some of them cost money and some of them are free. They come in different levels of professionalism, and DesignPH is one of those extensions. So it's just one amongst many extensions. And those extensions are all added or installed through the SketchUp interface. So you can add them. You can also offload them if you don't want to use them anymore. If they were giving you headaches for some reason, you can remove those extensions from your system as well. So that's all done through the extensions manager inside of SketchUp. So again, SketchUp is our base 3D modeling program. DesignPH is an extension for SketchUp. So we need both of those components in order for this workflow to work. And what does DesignPH get us? Well, DesignPH gets us a whole bunch of specific new tools, new functions, which get added to SketchUp, and they allow us to do our building information and energy modeling. So we get a whole series of new tools, which you kind of see in the toolbar on the left there, and that allows us to do all sorts of new tasks inside of SketchUp. So we get a bunch of additional functionality added to our modeling program there. One thing you just need to know, just up front, you have to turn on the DesignPH extension every time you start SketchUp. So by default, when you turn on SketchUp, the DesignPH is not running. If you want to run it, you just need to turn it on, and it's just a one button. You just click the button, and it boots up and turns on. But by default, it won't be operational. We'll see that in action in a few minutes. We'll sort of look at that workflow in a little bit more detail. So hopefully that's a good foundation. Hopefully that all makes sense. Obviously, if you have more questions about installing or versions or anything like that, feel free to add them to the chat or reach out after the session here. I'm more than happy to point you in the right direction. There's some very good websites for DesignPH that talk about what versions of SketchUp are compatible and all that kind of stuff. So now let's shift gears a little bit and let's talk about the basic workflow for SketchUp. Basic workflow for DesignPH. So what are the steps that we're going to move through if we're trying to utilize this software to actually design and evaluate our building for our Passive House certification? There are 6 basic steps that we're going to walk through. So we'll touch on them here. I'll outline them all here, and then we'll go into a bit more detail on some of these. So we'll look at some of them in a bit more detail. And then, as I said, future sessions, we'll dive into these in a lot more detail, or subsets of these in a lot more detail. So first of all, step 1, we need to model our building. So SketchUp's a 3D modeling program. We're going to model our building in 3D. So that's going to be one of the main steps here. We're going to take our time and do it properly. We'll talk about some of the specific issues around how we model. It's often quite different than the architectural model or the structural model that you might already have. We'll talk about where those differences occur. But in any event, we're going to model the geometry of our building. Once we have that base geometry, we're going to associate or tag that geometry with some intelligence. So we're going to turn that sort of dumb 3D model into a building information model. And it's a building information model, which is going to be purpose-built with an eye towards the energy model, the PHPP model. So we're going to associate or tag all of our geometry or various bits of our geometry in the scene with information. So we have to build out our building information model. We would then move into an analysis phase. So DesignPH includes a set of analysis functions. They've implemented some of the energy modeling inside of the Sketchup tool, but not all of it, just a few. So we can get a good preview of our analysis in our Sketchup tool. Once we're done with that analysis phase, we would then export out of Sketchup into the PHPP. And there are a couple steps associated with that. So first of all, we need to pull all of the relevant data out of Sketchup. We save it to something called a PPP file. That's just a special type of text file, special format. That PAPP file is then read into or imported into your PHPP file. So your PHPP energy model is the end result of all of your labors in SketchUp. So we build and associate, we build out the building information model. That data then flows into our PHPP model for final analysis and complete build out. And we'll talk about sort of how that works a little bit towards the end of today's session. So those are our main 6 steps. So let's look at those each in a tiny bit more detail. So let's dwell a little bit on especially the first couple, and then we'll certainly touch on those last steps as well towards the end of this session. So let's start our discussion here by talking about how we model with an eye towards our PHPP or DesignPH analysis. So modeling in the SketchUp environment. You're gonna have to model a 3D model of your building. You have to do it in a very particular way. It has to be done with an eye towards the final energy model. So the first thing to say about this 3D model that we have to create is that you're going to create it as a simplified planar energy model. That is, it's going to be made of simple, flat planes with no thickness. So for instance, if I was to cut away and look into this particular model, what you'll see is that none of those surfaces actually have any thickness associated with them. For our energy model, all we want is the surface area of that exterior skin. So we have to build or create a model here, which is just the outer skin of our building, a sort of balloon version of our building or a jello mold of the building. So often quite a bit different than your architectural model. So you can either sort of pull this information out of a complete architectural model, or maybe you rebuild it from CAD drawings. Lots of ways it can be done. But in any event, you have to have a completed, simplified planar energy model in order to interface with the PHPP properly. So we're going to build a no thickness, flat planar model. The other thing that we want to do is we want to strip away a lot of the detail. So for my energy model, what I want is a series of simplified flat planes. I want to strip away things like eaves and overhangs, parapets, footings, balconies, and the like. So for my thermal energy model, I want to create a simplified planar thermal zone mass. And that should be its own group on its own layer, should be its own set of geometry. And then once that's complete, I would then come in and add all those extraneous bits that might be contributing to my site shading. So in particular, things like overhangs, parapets, trim, porches, site grading, all of that would get added as a second layer of detail, but it would get added as its own group on its own layer as a fully separate set of geometry. And we'll look at why that is the case in a few minutes. The other thing to say is that for this step, for this initial step, we're going to model all of our windows as just flat planes. Nothing else. That's it. Just simple, single, flat, rectangular planes, coincident with our wall or roof geometry, whatever it is that's being hosted in. We're just going to model them as very, very simple rectangles. Note that the PHPP and DesignPH cannot do triangular or arched windows. It's only able to do rectangular windows. So if you have funny shaped windows, you're going to need to create a rectangle of equivalent area in order for the energy model to work properly. So that is one of the limitations for sure. So in any event, you're going to make a series of flat, simple planes. So Kayla is asking, where do you place the flat plane, at the cladding or at the insulation, vented space not included? Well, yeah, it's a good question. What you're really asking is, where do you put the wall? Right, the plane, it has to be coincident with the wall surface, because these are just flat planes. So you want those window planes to be coincident with the wall. So the real question is, where do you draw the edge of the wall? And it's a great question. The convention in Passive House land is to use what we call exterior dimensions. That is, we're going to measure to the exterior surface of the building. That won't always be the case. It sort of depends on how you built your U values, if that actually makes any sense. If you took the vented cavity into consideration when building your U values and the cladding, then you would just draw to the edge of the cladding. If not, you would draw to the edge of the insulation if you're doing continuous exterior insulation. So it sort of depends on where you drew your edge of your U value. Or maybe you would do it the other way. Maybe you build your U values to match where you put the edge of your surface or the plane of your surface. But somehow your U values and the position of the plane need to align. So that's really the critical alignment that has to happen there. But is flexible enough. You could do it either way. It really just depends on how you build those out. It's a good question though, for sure. One of the aspects of this modeling phase that often throws people for a loop is that it sometimes has to be split up in a way that's very different than the actual architecture or structure of the building. For our energy model, we want to understand which surfaces or entities are exposed to the ambient air, which are exposed below grade, which are maybe exposed to something like a loggia or a sun space or a garage. And so take a below grade wall. You know, the below grade wall that you see in the example here is one wall. It's one element of structure. It's one surface. But if part of it is below grade, part of it is above grade, then for purposes of the thermal model, the energy model, the load model, it's very common for us to actually split it into two surfaces for purposes of our analysis. So that's one of the sources of discrepancy that we often find, where we can't just take an existing architectural model and instantly perform our energy analysis on it. We need to clean it up. We need to strip away a whole bunch of detail. We need to sometimes split single surfaces into multiple surfaces, depending on exposure or U value type. There's a whole bunch of refinement and abstraction and clarification that we need to do as we're modeling out our geometry for use in the energy model. It's based on the same structure, of course, but we're going to split it up and analyze it in different ways, whether we're talking about an architectural representation or a thermal energy model. So one of the things we would do here is actually split this wall into two surfaces, one that we would call above grade and one that we would call below grade. Now, you may also be asking, looking at that last photo or that last image, wait, that's not actually what the bottom of the building looks like, right? It'll take a small single family home like this. You're going to have spread footings of some sort. You're going to have some sort of a detail at the bottom there. Shouldn't we be drawing that in? Shouldn't that level of detail be drawn in? Aren't we trying to create a very, very accurate energy model? And isn't that level of detail important? And the answer is, well, yes, that detail is critically important. It would not be accurate, though, for us to model it in a planar energy model like this. Instead, that's what our psi values are for. Our psi values are defined as the difference between the original planar energy model and the actual heat loss at our complicated junctions and corners. So for instance, in the sketch on the left there, we might have a simplified planar energy model that has a flat plane for the basement floor, a flat plane for the wall. They come together at some sort of perfect intersection, but the reality is that you have a complicated two-dimensional detail with some concrete and some kind of weird geometry happening there. Well, the psi value is what takes the extra heat loss of that actual geometry and material conductivity into account. So the psi values are correction factors that allow us to easily add detail to our planar energy model and accurately account for the two-dimensional heat flow that occurs at these complex junctions. So it's a more accurate and easier method of accounting for the extra heat loss that we see at these complicated construction junctions. This would be true at footings, this would be true at balconies, overhangs, eaves, parapets, corners, any place where we have an intersection between two construction elements, and we have a non-standard set of geometry or conductivities, we would use a psi value to account for that heat loss. So again, that's a more accurate method, and it's an easier method. It allows us to build our simplified planar energy model in a much more simplified fashion. All right, so once we have this model, once we have all of our geometry built into our 3D model, what do we do with it? How do we actually turn it into an intelligent model? How do we start to build out or tag elements of that model? And this is where we start to build out our building information model, which is going to flow into our energy model. So the first thing we have to do here is we have to turn on DesignPH. So in order for this to work, in order for you to be able to do this, we're going to need to start to use some of the new functionality built into DesignPH. And the way we do that is really quite straightforward. We're just going to click that little DesignPH button with the big red and yellow P. So that's how we turn on DesignPH. If you're following along, you might be yelling at the screen right now, wait, what? Where's that button? I don't have that button. I don't see that button. That's okay. If you're using 2019, a SketchUp version 2019 like I am, these little toolbars can be turned on and off. If you don't see the big red P, the easiest thing to do is go up to View, go to Tool Palettes, and make sure that there's a check mark next to the one that says DesignPH Toolbar. If there's no check mark, that means that toolbar is off. You just click it, it should turn on. You should see that little floating button appear somewhere on your screen. If it's already on, if it has a check mark next to it, maybe turn it off and turn it back on. It might be buried underneath another window somewhere, or maybe you're just not seeing it because it is a very small little button just floating around. So it might be floating in space somewhere. So in order to find that toolbar, it's relatively straightforward. Just go to View, Tool Palettes, and then turn on the DesignPH toolbar. So if you can't find it, that's where that would be. Oh, sorry, I missed another question there. Psi-values would only be used within PHPP, right? There's a question from Greg. No, it's a great question. Well, technically, I don't know how to answer this. Technically, no. Psi-values are not a creation of Passive House. It's a if you go to your ASHRAE Fundamentals Handbook, if you go to ASHRAE, or if you go to the ISO modeling procedures, they outline how to do psi-value calculations and how to quantify them. Psi-values were not something that Passive House invented. That said, most contemporary energy modeling programs, think ComCheck, eQuest, any of those, do not have any ability to take into account psi-values. And it's been one of the frustrations that we've had with those more typical energy modeling programs, and in particular, starting to build in thermal bridging analysis into building codes, is because a lot of the software available doesn't allow you to enter those values. That's changing though. Some of the new versions are going to allow you to build those in. And in particular, if you're working in New York City, there are now thermal bridge requirements built into the new version of the energy code that came out in March, and you're going to have to start to calculate psi-values moving forward. So for now, you're going to be able to pull your psi-values from a simplified table, which is built into the code, but probably in the next couple code cycles, you're going to be required to start modeling your own psi-values and building those into your models for code compliance once we're able to do that, things like ComCheck. Oh, sorry, I meant to say they would not be used within DesignPH, right? So it's a good question. In DesignPH 2, we do have the ability to actually enter psi-values and thermal bridges into our DesignPH model. So that's new with DesignPH 2. We were not able to do that before, but that is a new feature now. So we are able to manage that to some extent in DesignPH 2. So we actually would build them in. We can tag edges with psi-values. So that's a new feature there. So yeah, we would build that in. It's a good question. We're not going to cover that today. We'll get into that in a subsequent session because that's kind of a more advanced feature. So what happens when we turn on DesignPH? What happens when we click that big P button there? We get two things that happen. First of all, our toolbar sort of expands out and we get a whole new set of tools. And we are also presented with a floating window called DesignPH Main, and that's going to have a whole bunch of tabs that allow us to do all sorts of additional what do we want to say? Add in a bunch of additional detail and then review a whole bunch of additional results. So that's what we would do in that DesignPH Main window. Let's put that one aside for a second. We'll come back to that one. Let's just focus on that little toolbar on the left there. The DesignPH toolbar now lets us access a whole bunch of new DesignPH modeling and visualization tools, and that's going to be the primary one that we're going to use for the next few minutes here. So we'll come back to that DesignPH dialog window. For now, we can either minimize it or just sort of put it off to the side. And again, we'll come back to it. So we're going to use the new functionality, which is now available to us, to start to associate or tag geometry with some intelligence. And there's a couple ways to do it. The simplest way to do it is to simply select a surface using your left mouse button, and then right click with the right mouse button on that surface. And what you'll find down at the bottom of that context menu, which will pop up, is going to be a whole series of new functions which appeared when you turned on DesignPH. So these functions would not be available until you turn on DesignPH. But as soon as you do, these are now available, and they allow us to do things like select a surface and assign an exposure type. So for instance, I might select a wall, I might right click, I might scroll down to the bottom, hover over where it says assign area group face, and then select the appropriate exposure from the list that pops up. In this case, obviously, it would be group number 8, exterior wall ambient. If you're familiar with PHPP, notice that these are the same group types that we find in PHPP. We'll find that a lot in DesignPH. They mimicked or mirrored a lot of the existing PHPP nomenclature, and we'll see the same things pop up here in our DesignPH. So we might assign one wall surface, then I might move to the next surface. I'd grab the ceiling or the roof, I would right click, and then I, for this case, would assign it a group 10 roof ceiling or roof ceiling to ambient. And I would just go through one surface at a time, assigning each one to the appropriate type until I had completed all of the exterior surfaces. I would do the floors, I do the below grade walls, the above grade walls, the roofs, all the different types of elements. I would just go through and one by one assign them using that right click context menu. At this point, what we might do is turn back on all of our shading. So shading is a really important part of our overall energy model, obviously going to be critical for doing things like overheating assessment. And so we're just going to draw in all the shading as it actually occurs. We don't need to do anything kind of weird there. Just draw in whatever is shading your project, whether it's site shading, trees, hills, neighbors, roof overhangs, porches, whatever, just draw it in. And you're going to select that geometry. If you put it in its own group, that's pretty simple. Just open the group and do a select all. And you're going to assign it a special type. The special type is non-thermal. And the reason we do that is so that when we go to analyze and export the model, DesignPH will recognize those surfaces for purposes of shading calculation, but won't try and interpret them as roofs or walls or anything like that, any sort of heat loss surface. So we're going to build them as what are called non-thermal surfaces. So we just need to tag them that way, and then we're done with those at that point. Now, of course, beyond exposure, we need to go through each surface and we need to tag it with its appropriate assembly type as well. So using the same syntax where we would select a surface with the left mouse button, right click with the right mouse button, and then from the context menu that comes up, select a data type. We would do the same thing for assemblies. So in this case, we would scroll down to the bottom of the context menu, go to assign a U value of face, and then we'd have a different list that would pop up. This would be a list of all the available assembly types that we've built out in our DesignPH environment. And here you can see there's all of the typical pre-certified construction types, the same ones that you might find in your PHPP. And then, of course, there's going to be a whole set of user-defined custom assemblies that you're going to build out for your particular project. And we would just go through one surface at a time, or maybe we would do multiple at a time. You can select multiple surfaces and do multiple assignments as well, of course. But we would just go through one type at a time, tagging or applying these various types as appropriate to the different surfaces in the model. And where do these surfaces come from? Well, DesignPH has a surface assembly constructor, which looks just like the PHPP. So if you're familiar with PHPP modeling, you'll recognize this constructor. Same idea, you give it a name, some surface film resistances, and then layer by layer, we build in name, conductivity, and thickness. So Denise was asking, what's the way to adding custom U values? Does that get imported from PHPP? Oh, okay, good. Yeah, so you're going to use this methodology here. You're going to build them out just the same as you would in your PHPP. So you're just going to go through one layer at a time and build out each of the elements. So one layer or one heat flow path at a time and build out the elements. Now, I'm not going to lie, this is the worst part of DesignPH. This is not a database in any way, shape, or form. You can't copy these. You can't load them from another project. You can't save them out. You can't import them from PHPP. You have to just type them in one element at a time. And I'm not gonna lie, it's the worst. It's a constant source of error on our part. Anytime that you have a user, a human being, just typing in lists of numbers, that's a really typical place for errors to occur. It's very easy to put the decimal in the wrong place. And it's also just laborious in a way that it really doesn't need to be. But such is the way it is right now. This version of DesignPH doesn't allow us to do any sophisticated data management when it comes to our assemblies. We can be hopeful that the next version will include such tools. But right now we have to rebuild these in our DesignPH models, sadly. When you're all done, you'll have your completed model that'll have all of your various bits and pieces, all your surfaces and elements assigned, all your exposures assigned correctly, and all of your U values assigned correctly to each of those various surfaces as well. This will all flow into an overall collection inside of that DesignPH main window there. You can see we have a typical group breakdown at the top, and then a list of our user-defined assemblies at the bottom there, and then we see that it gets filtered and split up just the same way as our PHPP. Right? So exactly the same way that we might see this breakdown happen and filtering happen in PHPP, we see the same thing in our DesignPH. So we see that flow through here, and it gets broken up in a sort of particular way that the PHPP wants in order to do its heat transfer calculations. Now that brings us, of course, to windows. So far we've been talking about opaque surfaces, windows, walls, floors, roofs, shading. But what about more complex elements like windows? So in particular, elements that are going to have some glazing incorporated into them. How do we deal with those in our DesignPH modeling environment? Well, those are done using what are known as components. So those are a little bit different. We're not going to draw them per se. We said before in the earlier section, we draw our windows as flat planes. Then what we're going to do is actually convert those flat planes into window components or window objects. If you're not familiar with Sketchup terminology, a component is sort of like a block in AutoCAD or a family in Revit. It's a reusable parametric object which can be controlled and reused in different ways. So these windows are sort of smart objects in that they kind of understand a little bit about their construction. And the way that we're going to build them is, or the way that we're going to deploy them is not by building our own families or our own objects. We're going to use a converter, which is one of the tools that we got with DesignPH, to just take our flat plane. We're going to use this little button in the toolbar over here to just convert that plane instantly into a window family or into a window component. It's going to be a bunch of defaults that'll get rolled out on the window automatically when you convert it. But then obviously we can go in and set all the various parameters one window at a time, or maybe we can select a bank of windows and adjust all the parameters at once. However we need to for our project. What sort of parameters? Well, just the same ones you would use in PHPP. We want to set the glazing type. We want to set the frame type. We want to set the shading or the reveal depth. We want to set the installation situation on all four edges. Is it a mull up against another window, or is it installed in the wall, etc. So we're going to go through and tag or associate those various bits of information with each window. Where and how is all that data managed? That data is also managed in a sort of little catalog in DesignPH, which looks basically identical to the PHPP. We're going to enter all of our glazing types, all of our frame types. So for glazing, just like the PHPP, we have to put in an SHGC or a G value. We have to put in a U value for the glass. And then for the frames, we have to put in a U value for the left, right, top, and bottom, a face width for the left, right, top, and bottom, a Psi spacer for the left, right, top, and bottom, and then a Psi installation for a left, right, top, and bottom. So a lot of data that we would put in for each frame type there, and then we can build out, 30 or 40, 50, however many you have, frame types into our catalog here. Those can then get deployed on your specific window instances. One of the other things we would want to do is go through and set the reveal depth. So where is the window installed in the depth of the wall? Of course, the wall is just a flat plane in this model, but using these components, we can simulate that depth here. And obviously you can see that's going to affect things like the shading of the window. So we would go through and using our component options tool, which allows us to control the geometry using just simple parametric numerical inputs, we can control that backset depth by just typing in whatever the correct value is for the particular window that you're working on there. Of course, the other thing that we're going to want to do in this instance, or in this case, is manage that installation type as well. So for a situation like this, it would not be appropriate to have that reveal fin in between the windows, right? If these are molded together, the shading wouldn't be an appropriate calculation if we were to include that, and then the heat loss wouldn't be correct if we were to apply the Psi install along that edge, if it's actually molded to another window. And so we manage that using this little tool here in the toolbar. So there's a specific tool here that allows us to turn on or turn off the installation of those various edges. So we can turn them on or off, we can show them or hide them by using this little tool here. We could also go to the component options window and we could just choose hidden or off from the list. We have the ability to control the sill and the head and the left and the right from our component options window there. And you can see in the geometry preview on the sort of left-hand side there, the geometry modifies as we change the parameters in that component options window. So it's all controllable. We can turn them on and off. And what is that actually doing? Well, remember what that's doing in the PHPP. In the PHPP, we want to input either a 1 or a 0 for install situation, meaning yes, apply the Psi install, that's a 1, or no, do not apply the Psi install, that's a 0. So what this is doing in the end is controlling how the PHPP gets set up. Which of course brings us to our last topic here in our last 5-10 minutes before we take some questions and do a little live demo, which is exporting. So once we get all this data built into our DesignPH, once I've built my 3D model, once I've tagged all the assemblies, once I've built in all the building information that I would need to, what do I do with it then? How do I then get it out of DesignPH? How do I push it into a PHPP for certification purposes or to finish off the model with additional details? So it's a two-step process. So first of all, we need to analyze the model. So before we can export it, I need to analyze the model. And that's relatively straightforward. We press this little button here. It's a little bar graph looking thing. And the computer will go off and think for a little bit, might be 5 seconds, might be 30 seconds, sort of depends on how complex your scene is, but it'll think for a little while and then it'll pop up a result. So in our DesignPH main floating window there, all of a sudden we're going to see a bunch of results. It's going to start to show us our heat losses, our heat gains. It's going to tell us a bunch of information about our shading, etc. We could, at this point, start to add in a bunch more detail. We could add in information about climate, information about Psi-Values. We could enter in information about ventilation systems. We're going to skip over that for now, just to make sure that we actually cover the full workflow in this session. But again, we'll come back to those in future webinars for those different elements. But we could build out a bunch of additional information if we wanted. And once that's all done, once we've done whatever we need to do in the 3D environment, we're going to export. We're going to take all the data out of DesignPH. We're going to push it to the PHPP. And that's done using this export function right here. There's just a little button that we click the button, and it will ask us, where do we want to save out this PPP file? The PPP file is, as I said, just a text file, and it's just a record of all of the information in your DesignPH model, and it's just formatted in a very particular way so that the PHPP can read it. So it's a sort of interchange file that allows us to take data out of DesignPH and get it into the PHPP. So you can save that somewhere on your computer. Then this next step is a little funny, so stay with me and we'll cover it. Then, once you've saved that out, step 1 is open up a brand new, clean, and empty PHPP. So open up a brand new, clean, and empty PHPP. Then, with that still open, so minimize that, but keep it open, don't close it. You're going to navigate to your PHPP folder. So this is what you got when you purchased your PHPP. Most of us are familiar with that top folder there, O1 PHPP. That's where our starting PHPPs come from. But if you've ever poked around in the rest of these files you got when you purchased your PHPP, there's a whole bunch of other stuff in here. There's some other files around variants, some for economic comparisons, some for energy retrofits. There's some ventilation information. And then there's this file called PHPP en tools. So tools. This is a special type of Excel file that has some macros built into it. If you're not familiar with macros, they're just little widgets which can be built into Excel programs. It's just a sequence of steps, a little algorithm that's baked into an Excel program that allows us to do some repeated operations. And we know that because it's got that little letter M in its extension. Notice it's an XLSM file. What we want to do now is open this file. So we're going to keep that, we're going to keep the PHPP open, maybe minimize it, and then we're going to open this tools file. So we have them both open at the same time. That's important. We're going to go to the Import Export tab of this tools file. We're going to click the Import button. There's a couple other things here. We don't need to worry about them right now. The one we're most interested in is that Import button. If we click the Import button, we get a little dialog window that comes up, and it asks us two things. It says, okay, well, where would you like me to write to? And if you have that blank PHPP open, it should appear on this list. Maybe you save it out as like a temporary file to your desktop or something, but somehow you want it should appear on this list if it's open at the same time as this tools file. So that's going to be our destination. Then it says, all right, well, where do you want me to read from? And then we click this button that says select PPP. We get a standard, dialog window that allows us to navigate to a file. If you're on Windows or Mac or whatever, it'll look just the same. Just navigate to wherever you saved that PPP file. You saved it to your desktop or your project folder. Select the PPP file and click that Finish button in the bottom right-hand corner. The computer will go off and think for a while. It's going to read through that text file, grab a bunch of data, deploy it into the Excel file in various bits and places. After 20, 30 seconds, or depending on how long or how complex the building is, boom, you'll be presented with a mostly complete PHPP file. If you were to navigate to the areas worksheet, for instance, you should see all of your surfaces dropped in appropriately into the right locations. You'll see windows, you'll see components, you'll see different areas and surfaces. All of that will flow through from your DesignPH into this PHPP. At this point, save that PHPP. Don't just save it, do a save as. You never want to overwrite that original clean empty PHPP. That's always got to stay there. Save it as a new file with your new name, my new project, 01, May 18th or 19th, 2020, whatever your naming is. And at this point, we then need to go in and finish all sorts of elements in the PHPP. Which brings us to our last couple slides here. Some things to consider, some things to keep in mind when it comes to our DesignPH. Number one, this link between the PHPP and the DesignPH is not a live link. It's a one-way export from DesignPH into the PHPP. If I change something in the PHPP, it does not change back in the DesignPH model. And similarly, just because I change something in the DesignPH, until I export it out to the PHPP, it doesn't change. It's not in any way a live link. It's not really connected. It's just an export from DesignPH into the PHPP. In many cases, what we find is that it's actually easier to do a lot of experimentation, optimization in the PHPP rather than the DesignPH. What that means in practice is that the DesignPH is super important and it's a critical piece of our workflow. It's primarily used to manage geometry. That is to create geometry, assess shading, and then push it into a PHPP where we then build it out in a more robust fashion. We might use the variance worksheet at that point to do things like optimization, look at different versions, etc. That's often a lot easier in the PHPP than in the DesignPH. You'll also still have a lot of inputs in the PHPP which need to be completed at this point. Anything to do with mechanical systems, domestic hot water, cooling systems, passive ventilation, manual ventilation of windows, the variance worksheet, solar photovoltaics, all of that stuff needs to be completed in PHPP. There's simply no inputs for it in DesignPH. There's just no tools to allow us to manage that back in DesignPH. So DesignPH is important, but it only takes you part of the way there. You then need to finish everything off in PHPP. Note here also that those simulation preview results, so we saw very briefly that when we analyzed our model in DesignPH, we got some results. We saw some heating demand in, well, that's all we saw was heating demand. Those simulations are great, they're useful. They are previews only. They're not as accurate as the PHPP. In addition, DesignPH does not give any preview results for cooling, for primary energy, for heat load, or for peak heat load, or for peak cooling load. There's a lot of stuff we still want to know about our buildings, which is not present in the DesignPH preview. Again, what it kind of means in reality is the DesignPH is a super important piece of our workflow, but it's just that, it's just one piece. It doesn't take us all the way there. We still need that PHPP in order to get a complete energy model. Of course, when it comes to things like non-residential applications as well, there's no input whatsoever for non-residential usage patterns. We would have to then do that all in PHPP, which obviously has a much more robust non-residential set of worksheets for doing all of our space type allocation and user profiles. So in summary, DesignPH is an exporter. It's a hugely important piece of our workflow, but it's not a replacement for PHPP. It is not a replacement for PHPP. It's just one additional element that helps us do our jobs better and faster. With that, I'll be happy to take any questions. I could do a little bit of a live demo, certainly answer any questions, but before we do that, I just wanted to flag here really quickly, if you're looking for more DesignPH, if you want to understand more, because obviously this is such an important piece of our Passhouse Toolkit, we're going to be doing a full half-day workshop as part of the NAPHN Summer Conference. I'm not sure exactly the date for that yet, but we'll do a full half-day workshop where we can really dive into this stuff in a lot more detail. Andrew Peel, through Peel Passive, has a great intro to DesignPH, which is a fully online class. And then, as we talked about at the beginning of the session, here through New York Passive House, myself and Andreas and Amy are going to be putting together a series of these types of classes where we're going to dive into all of these aspects in a lot more detail. Keep an eye out for those. I think the first one that we have on the docket is June 2nd. That's going to be a deep dive into shading calculations. We're going to look at both geolocation, orientation, working in SketchUp off axes. We're going to look at SketchUp's shading analysis tools, and then we're going to dive deep into the new DesignPH 2 shading algorithms and inputs, which are significantly different than the older version. We didn't really touch on it today, but there's a whole radically new type of shading analysis which is done. And so we're going to dive into that next time when we have a little bit more time to really get into some of the meat here. So I guess it looks like, so yeah, so any questions at all? So it looks like we do have quite a few questions here. Let me field those first, and then we can certainly do some live demo here for sure. So Matt asks, can I save as the blank PHPP before populating it with PHPP data? Yeah, oh, good. Yes, you should do that. If anything errors during that import process, which, computer, power goes out or something, you don't want it to corrupt that source PHPP. You always want to keep that source PHPP sort of clean and like uncorrupted. So yeah, the best practice is open that and then immediately do a save as to make a new version of that Excel file. Sort of keep that clean copy off in a Dropbox folder or somewhere where you can always get back to it. So yeah, that's a good practice to do that. Save as before populating it. It's a great point. Can you re-import the same PHPP file? Suppose you import the PPP, then add a bunch of other info to the PPP, then decide to modify geometry. Yes, you can. Yeah, so great question. Let me go back just a few slides here to show. I sort of breezed right by it, but in the In the export options that we saw way back here, I sort of said you click that standard export. If you were to scroll down, you'll actually see there are several other export options here where you can export just the geometry or just the components or just this or just that. So there's different ways that you can sort of export sort of just certain segments. And then yes, you can always overwrite that in an existing PHPP. So yeah, it's a good question. Michaela asks, where do you place volume of the building in DesignPH? Good question. So that would be, we didn't go over this, but in the ventilation and internal heat gains tab that you can see on this screen right here is where we would build out information related to the ventilation systems volume of the building. So we would input that data there in that spot. And again, we'll go over that in a lot more detail in future sessions. Denise asked, to clarify your last point, is DesignP only residential? Well, it's a good question, right? Let me go. So as I said, when you do your analysis, you get this preview. This is what you see. So this is what we call a preview. As I said, this is not as accurate as the PHPP, but it's there to give you some preview, to tell you, roughly how are you doing. This preview assumes a residential occupancy, and there's no way to change that. You cannot change that in DesignPH. You can change that in the PHPP, though, obviously. PHPP has a very robust non-residential handler that allows you to model different space types, model different occupancy levels, model different energy densities, lighting, motion sensors, what have you. That's all doable in the PHPP, but not in DesignPH. What that means is this, for a non-residential application, this preview is not going to give you that much information. It's useful, but only so far. It's not going to give you the full picture. The other real downside to this preview is, what do you not see here is anything to do with cooling. So where I work in New York City and in much of the US, we want to look at heating and cooling at the same time. And there's simply no cooling calculations done whatsoever in the preview. So in order to get any really useful information, we end up you have to go to PHPP. And so the DesignPH is important. We don't spend a lot of time really looking at these previews. We don't find them to be super useful because they're not giving us a really complete picture. But obviously the interface is a critical element for building in any complex geometry. And then we haven't touched on it at all, but the shading is again really important and is done totally differently in DesignPH too.
But a future DesignPH will include cooling as well. That's what PHI is working on.
Mm-hmm. Great. And then Steve asks, do I have a preferred SketchUp extension for doing trees? Oh, good question. We didn't talk about this. I'm going to talk about that in the next one in a couple weeks. PHI, so when we work with PHI to do certification, they've actually given us some 3D trees that they like and told us to use them in our projects. So in our libraries, we kind of have a couple of 3D trees. I don't know where they came from. They modeled them. I don't know, some intern modeled them or something. They're complicated. They're, all the leaves are there and everything. But we can just copy and paste them into our scenes, and we can use them. You can turn the leaves on and off. They're nice trees, but again, we got those from our certifier. So I would say the first thing to do would be to ask your certifier if they have a tree model that you could use, and then they can certainly get those from PHI. As I said, we got ours directly from PHI. During some project, they said, "Oh, use this tree. We like this tree. This seems to work really well." But again, I'm not sure where they got it from. Certainly, although you could also model your own, or you could use any of them from the extensions warehouse. As I alluded to earlier, there's a whole universe of plugins and add-ons for SketchUp. That is both true on the tools side. So there's a bunch of tools that people have built as extensions, but there's also a bunch of models that are freely available. If you need a model of a chair or a model of a bed or a model of a stove, there's a sort of online marketplace where you can just grab those. They're typically all free. And that's also true of things like trees and landscape objects. You can grab those from the online repository there, depending on the type of tree that you have in your scene there. All right, so looks like we've only got a couple of minutes left here. So any last questions that anyone would like to go over before we wrap up here? Denise asks, there's also a TFA calculation in one of the buttons. Do I typically avoid TFA modeling? Oh, good question. No, not at all. We didn't talk about it here. We would typically draw out all of the treated floor area elements. You can tag those using DesignPH, so we can tag them as using our weighting system there, 100%, 60%, 50%. We would typically draw those to a very high level of detail. We would manage all of that geometric information using DesignPH. So in our actual projects, we always do that using DesignPH. Anything geometric, in my opinion, is managed well through DesignPH. And so that would include all of our TFA elements. And that, that's relatively straightforward. We just draw the rooms. We just draw the space shape of the rooms, both through TFA, and then we also do that for volumes as well. So that would also be true there. All right then. Well, I think if there are any other questions, I think we need to wrap it up there. We're running out of time here. So thank you all again for attending. I hope that was useful. I hope it was interesting. I hope it was a good introduction to the software. It's an important software. It's a critical piece of our Psi-Values toolkit, and we're thrilled to be able to show it. And again, look forward to doing a lot more of these in the future. If you guys have any questions at all about stuff as you get into it, feel free to reach out. That's what we're here for. We're happy to provide these type of learning resources through New York Psi-Values. And again, thanks to New York Psi-Values for sort of setting this up. And we'll look forward to many more in the future.
Thanks, Ed, for the fantastic presentation. And so we'll send you guys an email with a link to the video and also the chat transcript. And so you have also Ed's information he sent, so you have everything in one place. So join us for the next session, and happy hour on Wednesday, I guess.
Yeah,
yours was already, right? You did your happy hour, I guess.
Oh yes, if anybody didn't, if you guys hadn't seen it, I was presenting a bunch of stuff in the global Psi-Values happy hour last week, which was a lot of fun. Got a lively discussion, and that should be up online pretty soon. I think Dylan's still finishing editing it, but hopefully that'll be up on YouTube for everybody to watch if you didn't catch it. It was a fun discussion. It was a good time. So that one should be up on the Psi-Values Accelerator website pretty soon, hopefully.
Okay, fantastic. Thanks everyone.
Thank you.
Thanks, Ed. Thanks,
everybody. All right, have a good day.